The second method in data tabulation is relative frequency distribution. So relative frequency distribution is a type of descriptive statistics that express the frequency of each unique value in a data set as a proportion or percentage of the total observations. I'm repeating again. So the frequency of each unique value in a data set as a proportion or a percentage of the total observations. So let's look into the one example here. So if you see the IQ levels of various students in my class that I have written on left column, and after that I have calculated the frequency. So the 82 IQ I have one student, and 93 IQ I have two students, and again 131 IQ I have two students. Rest all are of 11111 frequency of IQ. So now what I did is I want to have a relative frequency distribution. Then the frequency, so 1 divided, so 24, so I have 1, and 1 divided by 24 will give you the percentage, a relative frequency distribution of IQ 82. And similarly 2 divided by 24 will give you the relative frequency distribution of IQ 93. So if you have doubt, let me do a small calculation and show it to you. Yep. So 1 divided by 24, it's 0 point. So okay, let me multiply. Let me put into the brackets 1 divided by 24 multiplied by, that's it. It's a 4.166, and then so you just round it off and you'll get the 4.2. And similarly 2 divided by 24 multiplied by 100, 8.33, and here it is 8.3. And that's how we have calculated the relative frequency distribution. So relative frequency distribution is expresses the frequency of each unique value in a data set as a proportion or percentage of the total frequency. So this is the unique frequency. This is the frequency of this unique 82 IQ, and which will be for the divided by 24 will give you the relative frequency distribution. So 1 divided by 24, 2 divided by 24, that will give you the relative frequency distribution. So let's take one example to get the clear-cut understanding of the same. So 3.2 relative frequency distribution. So in pandas you can easily calculate and visualize the relative frequency distributions using various functions and methods. So we will take one example here. So let me create a simple data frame. So I think I would have had this age. I have created age 1. Let me take the same one in spite of going for the ages. I don't think it's there. Okay, never mind. Let's create the new one. So create a data frame. So DFRFD is our data frame name, and pandas data frame. So age and a sequence of values 25, 3030, 22, 35, 28, and after 28 we'll go back to 30 and 35 again, then 30, 22, then 25, 22, 28, 25, 22, 28. So there ends our data frame. So now calculate let's calculate the relative frequency distribution of age column. So to calculate that, let me say relative freq and distribution is equals to df of age and let me directly apply the value counts, and after the value counts we need to give a special one, a special argument known as normalize. So in this example we used a value counts function or method with the normalize is a true argument to calculate the relative frequency distribution of the age column. The resulting output shows the relative frequencies of each unique value in the age column as proportions or percentages of the total observations in the data frame. So let me print. So rel, and something is wrong. So normalized, okay, D F R F D, and here is that fantastic response. So 0.25, 25, 166, 166, 166. So this is how your, if you sum it up all, you will get a 1. So here we got the percentages. Here we got the 0.25. So this is not the percentage, this is the value we got, the 0.25, 0.25, 0.25. If you convert that into percentages, it will become 25, 25, 16, 16, 16. Okay, so you can further customize the relative frequency distribution analysis based on your specific data set and analysis requirements. For example, you can round the relative frequencies to a specific number of decimal places or visualize the relative frequency distribution using a pie chart or other visualizations. We'll be doing that in later stage.